Okay, so our kind of motivating question here, when we're going to talk about precise definition of a limit, we're going to start out with an actual example. So let's say I gave you this piecewise function. F of x is 2x minus 1 as long as x doesn't equal 3, and it's 6 if x does equal 3. So we know something about what this would look like. It's essentially a graph with a hole in it. You would have a point at 3, 6. And this one, if you plug a 3 in here, you get out 5, so that would be an open circle. This is just a line, y-intercept -1, slope of 2. So you have this line with an open circle, and then you have a point. We've graphed piecewise functions. We could sketch that graph if we needed to. So by looking at that graph, I think we would all agree that the limit as you approach 3 is equal to 5, right? Because we don't care what happens at the point, we just care what happens as we get close to it. But if I wanted to be very precise about it, I might ask you, how close does my x have to be to 3 so that f of x, or y, differs from 5 by less than 0.1. In other words, if I want my y values to fall between 4.9 and 5.1, I want my y to be in that window, how close does your x have to be to 3 to make that happen? Because the idea of the limit, the closer I get to 3, the closer my answer should get to 5, right? So if I want an answer that's more precise, if I want a number that's closer to 5, you just have to get an x that's closer to 3. Okay, so that's kind of what our limit is asking. Now, we can measure distance with absolute values, because distance is always positive. So the distance between x and 3 is the absolute value of x minus 3. The distance between my y value and 5 would be the absolute value of f of x minus 5. Alright, so our problem is to find a number delta. Okay, we're going to throw in some new variables here. So delta is just a variable. Well, yeah, really the only time we use deltas will be right here. That's a better one. So that's my delta. So we need to find out delta so that the distance between my y value and 5 is less than 0.1 if the distance between my x value and 3 is less than delta. I have to find a window for my x's. Okay, so another way that we might look at this, absolute value is always positive, so you might also see it written that has to fall between 0 and delta. The 0 is kind of unnecessary because we know the absolute value is already positive, but just a different notation you might see sometimes. I typically won't require you to do that. Now, we could actually find that, okay? If I did 0.1 divided by 2, I get 0.5. Alright, so if the absolute value of x minus 3 is less than 0.5, and you don't really, or 0.05, you don't really know where I got that yet. We'll talk more about that part later. Then, what happens is my function, which the original function was the 2x minus 1, so I can plug that in. If I did that distance between x and 5, I get this absolute value of 2x minus 6. But you can pull a 2 out of there. You get 2 absolute value of x minus 3. But I already said that the absolute value of x minus 3 is less than 0.05. And 2 times 0.05 is 0.1. So what I just showed you is that if you picked an x that was within 5/100ths of 3, so if you pick an x value between 2.95 and 3.05 and plug it into that equation, you will get a y value that is between 4.9 and 5.1. this leads us into the formal definition of a limit, the actual definition. So we say the limit of f of x as x approaches a equals a number if for every number, okay, this is epsilon. So we have epsilons and deltas in this. Okay. Epsilon, for every number epsilon greater than 0. So for every positive epsilon, there is a positive delta. So that if the distance between x and a is smaller than delta, the distance between f of x and L is smaller than epsilon. Okay, if you want to think about this in practical terms, think about like manufacturing. You know, are every two parts made identical? No, there's a little bit of error, right? If they are making parts for a car, well, every two parts that come out of their machine have the exact same measurements. No. But they have a window of acceptable ranges, right? They have to be pretty close. And so they have to look at what ranges will fit. Notice it has to be within 1/1000th of the correct measurement or 1/100th of the exact measurement. And they have to look at what ranges would be acceptable in the final part and then tweak their machine to make that happen. So that's kind of what we're looking at here. That's like the formal definition of a limit. Alright, I put some pictures up here to kind of help because this is really abstract, really just because we're throwing all these epsilons and deltas and a's and f of x and L and all these letters in here at once. So the definition of a limit says that if any small interval, L minus epsilon and L plus epsilon, because epsilon is like the acceptable error. So if it were, you know, if my limit was 4 and my epsilon was 0.5, I would be between 3.5 and 4.5. Okay, so if you have a window for your y values, then you can find a window for your x's so that all of the x values in that window would fall in the acceptable y values. Okay, so basically you have to find this window for my x's so that anything I pick in here will give me an answer that falls in this range over here. It's finding out what x's would be acceptable. Just another graph to illustrate that. It's kind of showing you, if I were looking at this point right here, trying to find that limit. Okay, my limit is here, so I have some epsilon, some acceptable y value, or a range of my y values. And then you would have to find the x's that would correspond to it, which would be everything between here and here, right? If I'm, well, kind of depending on what your epsilon is. And you can narrow that down. You can make your epsilon smaller and it makes your delta smaller. So we are looking at that. All right, so we are going to actually talk about one. We are going to use a graph to help us try to find this. Find a number delta such that if the absolute value of x minus 1 is less than delta, then the absolute value of x cubed minus 5x plus 6 with a minus 2 is less than 0.2. Alright, so if I want to think about that, let's just talk about this function right here. I want to subtract 2 off this and do the absolute value and get something that falls within 0.2, right? So if I want to find the actual numbers this function falls between, then really what that tells me is when I subtract these things, I could have gotten negative 0.2, or I could have gotten positive 0.2. You're going to do absolute value. Okay, so if I wanted to solve for this function, if I add my 2 over, we get 1.8. If I subtract or added the 2 over on this one, I get 2.2. So the actual function itself needs to fall between 1.8 and 2.2. So that when I subtract 2 from it, the distance is less than 0.2 tenths. Okay, we are going to use the graphing calculator to find this. Okay, I'm going to type in this function, x to the third minus 5x plus 6. And I'm going to go ahead and do the 1.8 and 2.2 as 2 other functions. So it'll graph those lines for me. So I did 1.8 x cubed minus 5x plus 6 into 2.2 in my graphs. If you look at your standard viewing window, there's my x cubed function. There's my y equals 1.8, there's my y equals 2.2. I can't really see much, so what do I need to do here? Zoom in. Or you could even go and adjust your windows a little bit, whatever you preferred here. So I want this function to fall between these guys, 1.8 and 2.2. We can find that. It actually happens twice. It happens here and it happens again later. Let's just do the first one. We need to find these intersections. So we can do second trace. Number 5 is intersect. The first curve, I do want it to be my blue line here, so I'm going to go to automatically. The second curve, I want it to be my black one. So you can just use the up arrow until it tells you up at the top the function is 2.2, which is the higher line here. Guess. Just get close to it. And read it. 0.9114. We get 0.9114. Let's do the second one. So second trace intersect number 5. I want to know where this x cubed meets the 1.8. So make sure that's your first curve and second curve. Just get close to it for your guess. And I get an intersection of 1.124. Is that right? Mine's really blurry. I can't hardly read it. I only gives you. Okay, so we actually found that if I want my limit, if I want the actual y value to be within 2/10 of the actual limit, then my x value had to fall between these numbers. Okay, so if you picked an X in this window, it would give you a Y that fell in this window. Now, for the rest of this section, and all I would ask you guys to do on homework and quizzes, we are going to be doing a very generic. These are called, they're kind of proofs, the epsilon delta proofs, the formal definition of a limit. So what I am actually going to tell you, I will give you a problem, I will give you a function, I will tell you what the limit equals. And you are going to prove that it is true. To prove it, there are multiple ways to do it, but I'm going to show you one, and we are just going to use the same method over and over and over again. This is a proof, meaning if somebody else were to pick up your paper, they would have to be able to read it and agree with the reasoning. So this is not something where you just write down a final answer and box it in, because I'm already going to tell you what the limit is. Your answer is the explanation along the way. So this is not a type of problem where you are going to be able to shortcut it. You are going to have to write down exactly what I write down. Now the nice thing is, it's going to sound a little confusing at first, but every problem we're going to do from here on out is going to be identical, and you will see the pattern come through. So even though it's going to sound really abstract at first, it's actually not going to be very bad because every problem is going to be identical. Okay, we're just going to be switching some numbers. So, I'm going to skip that one, I think. To use our epsilon delta definition, the first thing we are going to do is, given some epsilon greater than 0. Epsilon is the number that's telling you how far you are from your limit. We are going to look at the absolute value of f of x minus L is less than epsilon to find a delta that works. And then we are going to prove it. Okay, easiest way to go through this, I think, is just by example. I think if I sit here and just go over these definitions, you're going to get hung up on all these different variables and not understand what I'm saying. So I really just want to start jumping in with some examples of these proofs and work through them. So we are proving that the limit as x approaches 3 of 4x minus 5 equals 7. Okay, this is a limit you guys can evaluate. You would have just plugged it in and you would have got 7 for your answer. But now you have to prove why that is true. Okay, so when we go through this, we are going to go step by step, clearly outline what we are doing. So our first step is kind of like our scratch work. Our goal here, I like to write down my goal, especially on these beginning problems. It helps a lot. We need to show if, and this is the formal definition of a limit. You will probably have, your last test had some multiple choice questions. I would probably put a multiple choice question on your next test saying which one is the formal definition of a limit. Okay, we need to show if the absolute value of x minus 3, because you're measuring the distance between x and 3, is less than delta, then the absolute value of the function, which was 4x minus 5, minus the limit, is less than epsilon. Okay, that formal definition that I put on the previous slide said if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. A is just the value your limit is approaching, f of x is the function, L is the limit. You're just plugging those pieces in. Okay, this, while it may not be an actual part of the proof that I would grade, I strongly encourage you to write this sentence down, because this tells you what you need to get at the end. So when you can say this at the end, you know you are done. All right, the first step we have to do here is find delta. To do that, we are going to work backwards from the second part. So to find delta, I am going to start with this piece. Okay, and that'll be every time. I'm going to start with that statement. So I know that 4x minus 5 minus 7 is less than epsilon. Okay, if I wanted to simplify this, that would be 4x minus 12. What do you notice about this? Can pull a 3 out. 3 is positive, so it just comes straight out of the absolute value. If it were like a negative 3, what would come out of my absolute value? I don't know why I wrote 3. If I were pulling out a negative, would you put a negative in front? No, it's absolute value, so what comes out is always positive. Okay, we have seen the absolute value of x minus 3 before. Where did I have that? Yeah, look at my goal. Right there. So let's solve for this absolute value of x minus 3. So what I need to do there is just divide my 4. We are done with step 1. Basically what we have done is found a formula. So if I wanted my y's to be within 1/10, my x's, you have to do 1/10 divided by 4 to get an acceptable window for your x's. Step 2 is the actual proof. So this is the step where I am really going to be critiquing. You can't just write down a bunch of work, you have to write an explanation along with it. We have to use this definition. So I'm going to start out, I'm going to say let delta equal epsilon over 4. That's the formula I just found up here. Then I'm going to go to my goal here. If the absolute value of x minus 3 is less than delta, then the absolute value of 4x minus 5 minus 7. Now I have to prove that that is smaller than epsilon. So once I get a less than epsilon in this problem, I'm done. Okay, we're trying to prove this statement. So I started out with this part. We need a less than and an epsilon, and then we're finished. Now, it seems kind of silly, but we're really just going to start out repeating the stuff that we just did. If you work through this, that's 4x minus 12. Pull out your 4. So that's 4 times the absolute value of x minus 3. But I know the absolute value of x minus 3 is less than delta, right? We've already assumed that. So that means this is less than 4 delta. Does everybody understand what I did that? Okay. I have my 4. The absolute value of x minus 3 from this sentence right here, I know I can assume that is smaller than delta. So 4 times this would have to be smaller than 4 times delta. We got our less than in our statement. So now all we need is an epsilon, and we're done. What is delta equal to? So this is 4 times epsilon over 4, which is epsilon. So my goal was that sentence I wrote at the top. We had to get that complete sentence. That was the definition to be done. I started out with the first part. Right there I got my less than, and right here I got my epsilon. So that is it. That means that the limit as x approaches 3 of 4x minus 5 does in fact equal 7. Okay, I know that was kind of like talking Greek for a little bit.
How is it 4 then equals 7? I don't understand.
Okay. Alright. So I want to prove that the limit as x approaches 3 of 13x minus 29 equals 10. First thing I recommend is let's write our goal. That is the sentence we have to get in our proof to be done. The definition of a limit is if the absolute value of x minus a, what is my a value? 3, is less than delta, then the absolute value of f of x, what is my f of x? 13x minus 29, minus my L, what is my limit? 10, is less than epsilon. That's what we need to prove. To do that, we have 2 steps. Step 1, find our delta. So to find delta, we're going to kind of work backwards from this epsilon piece. So I'm just going to copy that down. That's the value of 13x minus 29 minus 10 is less than epsilon. So if you combine like terms in there, what do you get? X minus 39 less than epsilon. What can you do right now? Pull out a 13. Absolute value is of 13 is 13. We have x minus 3 is less than epsilon. Notice we've seen that x minus 3 before. That was right here. What do I need to do to finish? Divide our 13. Okay, that was our step 1. That was kind of our scratch work. Step 2, this is your actual proof. This is the piece that I am really going to critique when I'm looking at these. We have to start out with the assumption we are going to let delta equal this thing we just found, epsilon over 13. Then we have to do the proof. So I am going to be able to write this first part. I'm going to write all of that down. And then I have to work it out and get a less than and an epsilon to be done. If the absolute value of x minus 3 is less than delta, then the absolute value of 13x minus 29 minus 10. And now I start working. But I'm just repeating the steps that we really already did when we found our delta. So first, we combine our like terms. Then, what do? Take out 13. Okay. Right here, I have the absolute value of x minus 3. But I've already said the absolute value of x minus 3 is smaller than delta. So this has to be less than 13 delta. So right now, I've got my less than. All we need to finish is our epsilon. But what is delta equal to? So that is 13 times epsilon over 13, which is epsilon. And we got our epsilon, we're done. So we just showed that the limit as x approaches 3, 13x minus 29 is in fact I want to prove this limit does equal 0. So our goal, that's the definition. Definition is if the absolute value of x minus a, what is my a in this one? Is less than delta, then the absolute value of f of x, which is cube root of x, minus L, what is my L, is less than epsilon. So step 1, we find delta. So we start with this epsilon sentence. What is the cube root of x minus 0? Just the cube root of x. How do you cancel a cube root? Cube it. But if you cube one side, you have to cube the other. So this means the absolute value of x is less than epsilon cubed. Keep in mind, we're going to be using, we have this x minus 0. Isn't that the same as saying the absolute value of x minus 0 is less than epsilon cubed? Okay, so that is our delta. Delta has to be epsilon cubed. So step 2, we have to first write that. Let delta equal epsilon cubed. Then we're going to write the first part of the definition. If the absolute value of x minus 0 is less than delta, then the absolute value of the cube root of x minus 0. And now we have to work it out to get a less than and an epsilon. But this is just the cube root of x. Alright. If you are going to take the cube root and an absolute value, does it matter which one you do first? Like, if I said the cube root of negative 27, what is that? Negative 3, and the absolute value is positive 3. Is that the same thing as if I did the absolute value of negative 27 first, and then did the cube root? The absolute value of negative 27 would be positive 27, and the cube root of 27 is 3. So the cube root and the absolute value could be done in either order, right? So this would be the same as saying the cube root of the absolute value of x. Okay, if it helps you, you wouldn't necessarily have to show me this, but realize the absolute value of x is the same as the absolute value of x minus 0. We know the absolute value of x minus 0 is less than delta. So right now I can say this is less than the cube root of delta. But what is delta? So that's the cube root of epsilon cubed, which is epsilon. So we showed that the limit as x approaches 0